Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2018. This is question number 8 from paper 2 from the topic Matrices and Determinant. One very important topic for JEE Advanced. In fact, this year we have seen multiple questions from this topic. Let us see what this question is. Let P be a matrix of order 3 into 3 such that all the entries in P are from the set -1, 0, 1. Then maximum possible value of the determinant of P is. Now to solve this question, we can assume P to have 9 entries A1, A2 up to A9, and its determinant then can be written as like A1, A2, A3 in row 1 and so on. All these A1 to A9 will belong to the set -1, 0, 1. This determinant I can expand along either rows or columns or by Sar's diagram. Let us expand it along row 1. So this will be A1 into A5, A9 minus A6, A8 minus A2 into A4, A9 minus A6, A7 plus A3 into A4, A8 minus A5, A7. Now I am writing those terms which are with plus sign in one bracket. So A1, A5, A9, then A2, A6, A7 plus A3, A4, A8. And let us call them as term 1, term 2 and term 3. And similarly, in another bracket, all the terms with minus sign. So A1, A6, A8 plus A2, A4, A9 plus A3, A5, A7. And let us call these terms T4, T5 as and T6. And because T1, T2, T3 and so on, they all are product of 3 elements of P which are coming from -1, 0 and 1. So all these terms I can say will be either equal to 0 or 1 or -1. So in order this determinant of P to be maximum, I think we should first try to make T1, T2, T3 as 1, 1, 1 and T4, T5, T6 as -1, -1, -1. So this determinant P will be equal to 6, or I think maximum of determinant of P will be 6 if this T1, T2 and T3 they all are equal to 1, 1, 1 and T4, T5 and T6 they are equal to -1, -1, -1. Now one very interesting thing, please notice that T1, T2, T3 if you see, you can find that all the terms A1, A2 up to A9 they are occurring exactly once either in T1 or T2 or T3. So if I multiply T1 with the T2 with the T3, in this scenario when they all are 1, 1, 1, this will give product of all 9 elements to be equal to 1. Whereas T4, T5, T6 are also having all 9 elements such that every element is occurring exactly once. So if I multiply T4 with T5 with T6, again we are getting all the terms A1, A2 up to A9 and this will be equal to -1. Okay, I hope you are getting my point. We can see at once we are getting all elements their product to be 1 and in another case we are getting -1. So T1, T2, T3 is equal to 1 and T4, T5, T6 equal to -1 simultaneously. It is just not possible. Okay, so we can say here, so maximum value 6 not possible. Okay, I will tell you another way why it cannot be equal to 6. Let us see. We can assume this determinant to be scalar triple product of 3 vectors, let us say P, Q and R, where this vector P is A1 I cap plus A2 j cap plus A3 k cap. Then magnitude of P we can write as less than or equal to √3 because its magnitude will be maximum if A1, A2, A3 all are from 1 or -1. Similarly, mod of Q will also be less than or equal to √3. And similarly, mod of vector r will also be less than or equal to root 3. Now, as we know, this scalar triple product represents volume of a parallelepiped also. So here, if I assume this parallelepiped has maximum lengths of edges as root 3, root 3, root 3, and they are perpendicular also to each other. In that case, volume of this parallelepiped will be maximum, and this can be, I should say, V max will be equal to 3 root 3, which is when all vectors are of maximum length and also they are perpendicular. Even this is less than 6, you can see. So again, this is another reason to say that a maximum value cannot be equal to 6. Now, because all T1, T2, T3 up to T6 can take integral values only, and we have ruled out that 6 is not possible, so my next maximum possible value can be 5. Okay, so next maximum possible value can be 5 if one of T1 to T6 is 0 and other are taking 1 or minus 1 so as to give us 5. I can assume any one of them to be 0. Let us say T1 is 0. And then, either A1 will be 0 or A5 will be 0 or A9 will be 0. Okay. But if A1 is 0 or A5 is 0 or A9 is 0, in all three possibilities, you can see this will make T6 to be 0, this will make T4 to be 0, and this will make T5 to be 0. So you can see if I make any one of the term to be 0, it will compulsorily make another term to be 0. So what we were assuming that I will make one of them as 0 and other 5 to be 1 or minus 1, it is just not possible. So once again, I can say that maximum value 5 is also not possible. Okay, now coming to next possible, that is I think 4. Okay, now we can assume that T1 was 0 because of any one of the element of this becoming 0. Let us say A1 is 0. Okay, and then as I was telling you in the previous slide, also this T6 will also be 0. Now let us try to make T2, T3 as 1, 1. Okay, and T4 and T5 as minus 1, minus 1, so that my next target or next maximum possible value 4 is possible. Now let us try to see if that is possible or not. T2 is equal to 1 can be if I take A2, A6 and A7 to be equal to 1, 1, 1. T3 can be equal to 1 if I take A3, A4, A8 equal to 1, 1, 1. In fact, T2, T3 can be 1, 1. In other cases also, when two of them are minus 1, one of them is 1. But I'm just exploring the possibility if that is possible or not in one of these scenario. Okay, now if these 6 elements are 1, 1, now to make T4 equal to minus 1, please see, I have already said A3 as 1. Okay, I have already said A7 as 1. So if I take A5 as minus 1, I think T4 will become equal to minus 1. Okay, and this A5 is equal to minus 1 will not make any difference to other terms because it was occurring in only T1, which is 0. So even if A5 is 1, minus 1, whatever it is, T1 will remain 0 only. Now same way, T5 can be made minus 1 if A9 is equal to minus 1. Okay, so this is how you can see that determinant of P can be equal to 4. And because 6, 5 were not possible, so this maximum possible value, of this determinant P is nothing but 4 only. Okay, so this is my answer for this question. So this completes the solution for this question. I hope you like this solution. Thank you so much. Stay tuned for more questions. Bye.